Have you ever wondered what you are actually touching? Look at your hand right now. Hold it up in front of you. Press your thumb against your index finger. Feel the pressure. Feel the texture of your skin, the warmth, the resistance. It feels solid, does it not? It feels unbroken, continuous, a barrier of matter meeting matter. This is the sensation that has defined every moment of your life. The feeling of the chair beneath you, the ground under your feet, the phone or computer you're holding. We live in a world of surfaces, of things that bang and collide and hold their shape. But this sensation is a lie. If you could shrink yourself down, smaller than a grain of sand, smaller than a cell, smaller than a molecule, you would find that the solidity you trust so implicitly simply vanishes. You would find that you are not touching anything at all. In fact, you have never truly touched anything in your entire life. What you feel as touch is actually a force field, a magnetic resistance between clouds of particles that never actually meet. You are hovering. You are always hovering, separated from the rest of the universe by a tiny, insurmountable gap. And if you look closer, past that gap, past the illusion of surface, you enter a realm that is almost entirely empty. The atoms that make up your body, the air you breathe, the stars in the night sky, they are 99.99999% empty space. This is not a figure of speech. This is not a poetic exaggeration. It is the cold, hard, scientific truth. We are ghosts made of void, drifting through a universe that is mostly silence. Welcome to the journey into the core of a quantum particle. If you enjoy exploring the boundaries where science meets the strange silence of the unknown, please take a moment to drift with us. It helps us bring more content like this to you, and it lets us know that you want to keep exploring the deep mysteries of existence together. Now, let us begin our descent. To understand the ghost-like nature of our reality, we have to let go of the world we see. We have to peel back the layers of the macrocosm. Imagine for a moment that we can magnify the tip of your finger. At first, you see the ridges of your fingerprint like canyons on a desert planet. Go deeper. You see the skin cells, vast biological factories buzzing with activity. Go deeper still. You see the twisted ladders of DNA, the proteins folding and unfolding. These are still huge structures in the eyes of a physicist. We need to go smaller. We pass into the realm of molecules, where atoms lock together in geometric patterns. And finally, we arrive at the atom itself. For thousands of years, humans wondered what this thing was. The ancient Greek philosopher Democritus walked along the Aegean coast and held a stone in his hand. He wondered if he cut the stone in half and then cut the half in half and kept going forever, would he eventually reach a piece so small it could not be cut? He called this theoretical particle atomos, the uncuttable. He imagined them as solid little billiard balls hooking together to make the world. For centuries, that was the model. Solid spheres, little marbles of reality. But in the early 20th century, a scientist named Ernest Rutherford did something that shattered that image forever. He fired tiny particles at a thin sheet of gold foil. He expected them to bounce off, like tennis balls hitting a wall. Instead, almost all of them flew right through the foil as if it were not even there. Only a tiny fraction bounced back. Rutherford realized something profound. The gold foil was not a wall, it was a wire fence. Actually, it was mostly holes. He discovered that the mass of the atom was concentrated in a tiny, tiny speck in the center, the nucleus, and the rest was just empty. How empty? Let us build a scale model in your mind. Imagine we take a single atom of hydrogen and expand it until it is the size of a great football stadium. You are standing in the highest seats, looking down at the pitch. In the very center of the field, on the 50-yard line, sits a small marble. That marble is the nucleus. That is where almost all the mass is. And the electron? The electron is a gnat buzzing around the very highest seats of the stadium, blurring with speed. And between the marble in the center and the gnat in the stands, nothing. Absolutely nothing. Just vast, empty silence. If you are the size of that atom stadium, the distance between the nucleus and the electron is immense. It is a void so large that it defies intuition. Now, remember that your body is made of these stadiums, billions upon billions of them, and in every single one of them, the seats are empty. The field is empty. The parking lot is empty. There is just a marble and a distant gnat. If we could somehow remove all that empty space, if we could squeeze the electrons down until they touched the nucleus, the entire human race, all 8 billion of us, would fit inside a single sugar cube. Let that sink in. The physical matter that makes up every human being who has ever lived, every king, every peasant, every soldier, every lover, every child, all of it could be compressed into a thimble. The rest is just the geometry of emptiness. We are inflated balloons of void, tricked into thinking we are solid. So, why do you feel solid? Why, when you sit on a chair, do you not fall straight through it? Why does your hand not pass through the table like a ghost? The answer lies in the gnats, the electrons. These tiny particles carry a negative electric charge. And as you know from playing with magnets, like charges repel, when you bring your hand close to the table, the cloud of electrons surrounding the atoms in your hand pushes against the cloud of electrons surrounding the atoms in the table. They do not touch. They never touch. The electromagnetic force becomes so strong as they get close that it stops them before they can make contact. The sensation of touching the table is actually the sensation of your electrons being repelled. It is the force of the universe pushing back. You are levitating on a cushion of electromagnetic energy, hovering a nanometer above the surface of reality, forever separated from the world you seek to hold. This realization brings a strange kind of loneliness, but also a profound beauty. It means that connection, true physical connection, is an impossibility in the classical sense. We are islands of energy, signaling to each other across the gap. But our journey is not to stop at the electron. We want to know what is hidden in the dark heart of the atom. We want to descend from the empty stands of the stadium and walk down to that marble on the 50-yard line. We want to enter the nucleus, because the nucleus is where the real mystery begins. For a long time, scientists thought the nucleus was just a clump of positive charge, a simple solid center. But as we looked closer, we found that the marble is not a marble at all. It is a cluster, a chaotic, vibrating cluster of smaller particles called protons and neutrons. Imagine you are shrinking again. You leave the distant orbit of the electron. You fall through the vast vacuum of the atomic void. It takes a long time to fall this far. The silence here is absolute. There is no air, no sound, no light as we know it, just the potential of fields stretching out in the darkness. As you approach the center, you see them, the protons and the neutrons. They are huddled together, bound by a force so powerful it is literally called the strong nuclear force. This force is 137 times stronger than the electromagnetic force that keeps the electrons away. It is the glue of the universe. Without it, the protons, which all have positive charges and hate being near each other, would fly apart, and every atom in your body would explode instantly. But they stay together. They vibrate. They dance. If you look at a textbook diagram, protons and neutrons look like neat little red and blue balls glued together, static, boring. But reality is never boring. In the real quantum world, the nucleus is a storm. It is a boiling, seething liquid drop of matter, shape-shifting, breathing, oscillating billions of times a second. It is alive with energy. And here is the question that drove physicists to the edge of madness in the 20th century. What are the protons made of? Are they the bottom? Is the proton the fundamental brick of the universe? If you had asked a scientist in 1950, they might have said yes. They might have told you that the proton was a solid point of mass. But then we built bigger machines. We built particle accelerators, vast rings of magnets buried underground, designed to smash these particles together at nearly the speed of light to see what would break. And when we cracked the proton open, we did not find a solid center. We found three smaller things inside, three little points of light swirling in a frantic dance. We called them quarks. This is where the story gets truly strange. A proton is made of three quarks, two up quarks and one down quark. A neutron is two down quarks and one up quark. These names, up, down, mean nothing in terms of direction. They are just labels, like flavors of ice cream, chosen by physicists who had run out of Latin words. So, is that it? Are we done? Is the universe made of Legos called quarks? Not quite, because when we tried to measure the mass of the quarks, we found something that did not add up. We measured the mass of the proton. It is a specific number. Then we measured the mass of the three quarks inside it. Logic dictates that the mass of the whole should equal the sum of the parts. If you have a bag of 3 apples, the weight of the bag is the weight of the 3 apples. But in the quantum world, logic is a visitor, not a resident. When we added up the mass of the 3 quarks, they accounted for only about 1% of the mass of the proton. 1%. Let that echo in the silence of your mind for a moment. 99% of the mass of the proton, and therefore 99% of the mass of you and the earth and the sun, does not come from the particles themselves. Where is the missing mass? Where does the substance of the universe come from, if not from the stuff it is made of? It comes from the nothingness between the quarks. The inside of a proton is not empty, like the space between the nucleus and the electron. It is a chaotic ocean of energy. The quarks are held together by particles called gluons, glue particles. These gluons are constantly popping into existence and disappearing. They fly back and forth between the quarks at the speed of light, binding them together. The energy of this movement, the frantic, violent speed of these gluons, creates the mass. Einstein taught us that energy equals mass times the speed of light squared. X $. Mass is just trapped energy. So, when you step on a scale, the number you see is not the weight of solid particles. It is the weight of energy. It is the weight of the frantic motion of gluons and quarks spinning inside the atoms of your body. You're not made of stuff. You're made of movement. You're a localized storm of energy, confined in a trillion tiny vessels. This is a beautiful and terrifying thought. It suggests that solidity is an emergent property. It suggests that if the motion stopped, the mass would vanish. We are, in a very real sense, made of light and vibration, held in a tight pattern. But we are not done. We have reached the quark. We have seen the storm of gluons. But what is inside the quark? If we zoom in on a quark, what do we see? Is it another layer of smaller particles? Is it a universe of its own? Or is it something else entirely? To answer this, we have to push our imagination to the breaking point. We have to go to the limits of what is measurable. We have to enter the realm of the string. Current physics tells us that quarks appear to be point particles. That means they have zero size. They are mathematical dots. But a dot with zero size cannot have mass, can it? How can something with no dimension exist? This paradox leads us to the edge of known science. It leads us to the theories that try to explain the very fabric of reality. String theory suggests that if we could magnify a quark a billion times more, we would find that the point is not a point. It is a tiny, vibrating loop of energy. A string, like a guitar string, it can vibrate at different frequencies. If it vibrates one way, we see an electron. If it vibrates another way, we see a quark. The music of these strings creates the particles of the universe. But this is theoretical. We have never seen a string. We may never see one. What we do know, what is verified by every experiment we run, is that as we go deeper into the core of the particle, matter dissolves into fields. Think of the ocean. You see a wave moving across the surface. Is the wave an object? Can you pick it up? No. The wave is a behavior of the water. It is a disturbance in the field of the ocean. In the same way, an electron is not a little ball. It is a wave in the electron field. A quark is a wave in the quark field. The universe is not a collection of things. It is a collection of fields, layering over each other, vibrating, interacting. We are ripples. We are fluctuations in the quantum vacuum. So, what is hidden in the core of a quantum particle? In a way, the answer is everything. And in another way, the answer is no thing. We have descended from the hand to the cell, from the cell to the molecule, from the molecule to the atom, from the atom to the nucleus, from the nucleus to the quark. And at every step, we found that the solidity we expected was missing. We found void, we found forces, we found motion, we found energy, but we never found the solid stuff we started looking for. It is like peeling an onion, looking for the core, only to find that the onion is all layers and no center. And yet, here you are. You exist. You are conscious. You can feel the phone in your hand. The illusion is perfect. The void holds itself together with such strength that it builds mountains and oceans and living, breathing beings. This is the great paradox of our existence. We are built on a foundation of emptiness, yet we are full of experience. We are made of transient flashes of energy, yet we endure. As we prepare to dive even deeper in the chapters to come, ask yourself, if I am made of empty space and vibrating energy, where does I reside? Where is the thinker of these thoughts? Perhaps consciousness is not something separate from this dance. Perhaps it is the music itself. We have only just scratched the surface of this mystery. We have looked at the structure, but we have not yet looked at the strange rules that govern this world. The rules of the quantum realm are not the rules of our world. Down there, things can be in two places at once. Down there, the past and the future blur. Down there, observing something changes it. In the next part of our journey, we will step into this hall of mirrors. We will explore the dual nature of reality, the wave and the particle, and the experiment that proved the universe knows when you are watching. Rest now in the knowledge that you are a complex masterpiece of energy, a symphony of vibrations singing in the vast silence of the cosmos. You are not small. You are dense with the mystery of creation. Have you ever stood in a dark room and felt the presence of something you could not see? Maybe it was just a coat rack in the corner or a chair, but until you turned on the light, it felt like something else. It felt fluid, undefined, a shape shifting in the shadows. And the moment you flipped the switch, the moment the light hit it, it snapped into place. The monster became a coat. The ghost became a chair. We think of this as a trick of the mind, a failure of our senses to perceive what is already there. We assume the chair was always a chair, sitting in the dark, solid and definite, waiting for us to see it. We assume the universe is a stage that exists whether or not there is an audience to watch the play. But what if the universe is shy? What if reality does not actually decide what it is until you look at it? Welcome back to our quiet journey into the deep machinery of existence. We have left the hollow atom behind, and now we drift into a realm that is even stranger. We are entering the Hall of Mirrors. We are stepping into the mystery of the observer. This is the story of the most famous, most repeated, and most mind-bending experiment in the history of physics. It is a story that suggests that you, yes you, the conscious observer, are not just watching the universe. You might be helping to create it. Let us settle into the stillness of the laboratory. Imagine a room, perfectly dark, perfectly silent. The air is still. In the center of this room stands a machine. It is an electron gun, a device capable of firing tiny particles of matter, one by one, like a gentle stream of pebbles. In front of this gun, there is a barrier, a wall, with two vertical slits cut into it, two narrow doorways into the unknown. And behind that barrier, on the far wall, lies a detector screen, a special canvas that glows with a tiny spark of light whenever an electron hits it. This is the stage for the double-slit experiment. It sounds simple. It sounds like high school physics. But hidden within this setup is a ghost that haunts the dreams of scientists to this day. To understand the ghost, we must first understand what should happen. If we were firing tiny marbles at a wall with two holes, most of the marbles would bounce off the wall, but some would go through the left hole, and some would go through the right hole. On the back wall, you would expect to see two bands of marks, a pile of marbles behind the left slit and a pile behind the right slit. Two simple stripes. This is how matter behaves. It travels in straight lines. It is solid. It is predictable. Now, imagine we change the game. Instead of marbles, we use water. We place the barrier in a pool of water and push a wave toward it. The wave hits the barrier and splits. It goes through both slits at the same time. On the other side, two new waves emerge, spreading out like ripples from two stones thrown into a pond. As these two waves spread, they crash into each other. Where two crests meet, they make a bigger wave. Where a crest meets a trough, they cancel each other out, creating flat water. This is called interference. And on the back wall, you would not see two bands. You would see a complex pattern of many bands, bright, dark, bright, dark. This is the signature of a wave. This is the song of energy, not matter. So, we have a clear distinction. Particles make two bands. Waves make an interference pattern of many bands. Matter is marbles. Energy is water. The universe is divided. But the electron does not care about our divisions. We turn on the electron gun. We fire the electrons at the double slits. Remember, electrons are particles. We have measured their mass. We can count them. We can hold them in magnetic traps. They are tiny, distinct things. So we expect them to act like the marbles. We expect two bands. We watch the screen. Spark, spark, spark. The electrons hit one by one. Slowly a pattern begins to form, and as the pattern emerges, the scientists in the room stop breathing. The silence deepens. It is not two bands. It is an interference pattern. It is a series of stripes. bright and dark, spreading out across the screen. This should be impossible. How can single particles create a wave pattern? If an electron is a marble, it has to go through one slit or the other. It cannot go through both. If it goes through the left slit, it does not know the right slit exists. How can it interfere with itself? How can a single pebble ripple like water? The only explanation is that the electron, this tiny speck of matter, somehow dissolved. As it approached the barrier, it ceased to be a point. It became a cloud of possibility. It became a wave of potential. It traveled through the left slit and the right slit simultaneously. It interfered with itself in the space between the barrier and the screen, dancing a ghostly waltz with its own shadow. And only when it hit the back wall did it decide to become a particle again, landing in a specific spot determined by the probability of the wave. This is the concept of superposition. The electron is not here or there. It is here and there. It is everywhere at once, a shimmering haze of maybe. But the mystery gets deeper. Because the human mind, the curious, desperate human mind, refuses to accept this. We say, no, that is magic. We want to see it happen. We want to catch the electron in the act. So, we change the experiment. We place a tiny sensor, a watcher, right next to the slits. This sensor will beep very quietly if it sees the electron go through the left slit, and it will beep if it sees it go through the right slit. We are going to spy on the ghost. We are going to force it to reveal its secret path. We turn on the gun again. We fire the electrons. The sensor is watching. The universe is waiting. The first electron flies. Beep. The sensor sees it go through the left slit. Aha, we say. It is a particle. It went left. The next one flies. Beep. Right slit. We are triumphant. We have tracked the path. We have proven that the electron is a solid little marble that chooses a door. But then we look at the back wall, and the blood drains from our faces. The interference pattern is gone. There are no ripples. There is no wave. There are just two simple, boring bands of impact. Pile on the left, pile on the right. The electron knew. It knew it was being watched. The moment we observed it, the moment we asked, which path did you take, the electron stopped behaving like a wave and snapped back into behaving like a particle. It shed its ghostly coat of possibilities and became a solid, single thing. This is the observer effect, and it is arguably the most profound discovery in the history of science. It tells us that observation is not a passive act. You cannot just stand outside the aquarium and watch the fish. Your face pressed against the glass changes the behavior of the fish. The act of measuring the universe changes the universe. When the sensor was off, the electron was a wave of infinite potential. It explored all paths. It was free. When the sensor was on, the electron collapsed into a single reality. The wave function, the mathematical description of all those possibilities, collapsed into a single point of fact. What does this mean for us? What does this mean for the reality you are walking through right now? It implies that at the fundamental level, the universe is not made of hard, fixed objects. It is made of potential. It is a vast, shimmering ocean of what could be. And somehow, the act of interaction, the act of measurement, the act of consciousness meeting matter, forces that potential to freeze into what is. Think of the tree falling in the forest. The old philosophical riddle asks, if no one is there to hear it, does it make a sound? Quantum mechanics whispers a strange answer. If no one is there to interact with it, the tree might not even be a tree in the way we understand it. It might be a cloud of probability, a smear of quantum states, only resolving into wood and bark and crashing sound when the universe demands an answer, when a bird or the air or a human ear interacts with it. We are not just inhabitants of this cosmos. We are participants. We are co-authors of the story. This idea is unsettling, but it is also deeply gentle. It suggests that the rigidity of the world is an illusion. The hardness of your problems, the stubbornness of the obstacles in your life. At the quantum level, they are fluid. They are not fixed until the moment of collapse. Let us drift deeper into this idea of the collapse. Imagine a cloud in the sky. It is fluffy, indistinct, changing shape with the wind. This is the electron before observation. Now, imagine that cloud instantly freezing into a block of ice, the exact shape of the cloud, the moment you look at it. That is the collapse. But what causes it? Is it the machine? Is it the light? Or is it us? The great pioneers of quantum physics, Niels Bohr, Werner Heisenberg, Erwin Schrodinger, they debated this late into the night. Bohr argued that there is no deep reality. He said, "It is wrong to think that the task of physics is to find out how nature is. Physics concerns what we can say about nature." He believed the electron has no position until we measure it. It literally does not exist in a specific place. It is a ghost until summoned. Einstein hated this. He hated the idea that the universe was a game of dice, a fuzzy haze of probability. He famously said, "I like to think that the moon is there, even if I am not looking at it." He wanted a universe that was solid, reliable, independent of our clumsy probing. But experiment after experiment, for 100 years, has sided with Bohr. The universe is fuzzy. The universe is probabilistic. The universe waits. There is a variation of the double-slit experiment that is even more mind-bending. It is called the quantum eraser. In this version, we set up the watcher to see which slit the electron goes through. But then, after the electron has passed the slits, but before it hits the screen, we scramble the information from the watcher. We erase the knowledge of which path it took. Common sense says it shouldn't matter. The electron already passed the slits. It already chose a path. The deed is done. But when we erase the information, the interference pattern comes back. The wave returns. It is as if the electron went back in time, realized we weren't going to know which path it took, and decided to act like a wave after all. The present choice to erase information changed the past behavior of the particle. Time itself, in the quantum realm, is not a straight arrow. It is a tangled web. The past and the future are holding hands, whispering secrets to each other across the silence. This is where the science begins to feel like a dream. We are drifting in a boat on a sea of paradoxes. The water is calm, but the depths are bottomless. If the universe requires an observer to snap into focus, what does that say about the early universe? Before there were eyes to see, before there were minds to measure, was the cosmos just a vast, uncollapsed wave function? A silent symphony of possibilities waiting for a listener. Some physicists suggest that observation doesn't require a human mind. It just requires interaction. An air molecule hitting the electron counts as an observation. The environment itself is constantly watching, constantly measuring, constantly forcing the quantum ghosts to become solid reality. This is called decoherence. The universe is constantly observing itself, collapsing its own waves, knitting itself into solidity moment by moment. But even in this view, the mystery remains. Why? Why does the universe prefer solidity? Why does the ghost choose a chair? As you lie here, thinking about these particles, realize that the atoms in your brain are doing this dance right now. The neurons firing to create your thoughts are relying on the flow of ions. on the movement of electrons. Your very consciousness, the I that is wondering about the universe, is built on a foundation of quantum uncertainty. You are a wave function that has learned to observe itself. And perhaps that is the most beautiful thought of all. In a universe of mostly empty space, in a cosmos of probability and ghosts, you're a focal point. You're a center of collapse. You're a machine that turns maybe into is. Every time you open your eyes, you're painting the world. Every time you listen, you're composing the song. You're not small. You are the mechanism by which the universe becomes real. The silence of the quantum realm is not an empty silence. It is a pregnant silence. It is the silence of a held breath before a word is spoken. It is the silence of the dawn before the sun breaks the horizon. It is full of potential. We have seen that matter is empty. We have seen that matter is a wave. We have seen that reality depends on the watcher, but we still have not reached the bottom. There is another layer to this mystery, a phenomenon that Einstein called spooky action at a distance. What happens when two particles interact and then separate? What happens when they fly to opposite ends of the universe? Do they remember each other? The answer is yes, and the bond between them breaks the speed of light. It breaks the rules of space. It suggests that separation is an illusion. In the next chapter of our journey, we will explore quantum entanglement. We will discover how two hearts, once connected, can never truly be separated, no matter how vast the distance between them. We will see how the universe is woven together into a single, indivisible sheet of reality. But for now, rest in the uncertainty. Let the wave wash over you. You do not need to be solid right now. You do not need to choose a path. You can be the cloud. You can be the interference pattern. You can be everything at once. Drift in the probability. Float in the silence. The universe is waiting for you to decide what comes next. Have you ever felt a sudden, inexplicable pull towards someone you love, even though they were thousands of miles away? Have you ever picked up the phone to call a friend, only to find them calling you at that exact second? We call these moments coincidence. We call them intuition. We dismiss them as tricks of memory or the law of large numbers. We tell ourselves that minds are separate islands, locked inside the bone cages of our skulls, unable to touch except through words and signals that travel slowly through the air. We believe that to touch someone, you must be near them. We believe that influence fades with distance, like the ripples of a stone dying out in a vast lake. But deep in the quiet machinery of the universe, there is a rule that defies this belief. There is a bond that ignores distance. There is a connection so profound, so immediate, and so intimate that it suggests the very concept of separation might be a grand illusion. Welcome back to our journey into the fabric of reality. We have stood in the empty stadium of the atom. We have watched the electron dissolve into a ghost wave. And now we stand on the precipice of the strangest discovery of all. We are about to explore the phenomenon that Albert Einstein, the greatest mind of the 20th century, refused to believe. He mocked it. He fought against it until his dying day. He called it spooky action at a distance. Today, we call it quantum entanglement. To understand this mystery, we must first go back to the idea of birth. In the quantum world, particles are often born in pairs. Imagine a single burst of energy, a tiny explosion in the subatomic vacuum. Out of this flash of light, two electrons are created. They are twins. They are forged from the same source at the same moment, sharing the same initial properties. Because of the laws of conservation, the strict accounting rules of the universe, these two particles must balance each other out perfectly. One of the properties they possess is a quality physicists call spin. Now, do not imagine the electron spinning like a top or a planet. That is a metaphor, and, like all metaphors in the quantum realm, it falls apart if you lean on it too hard. Quantum spin is more like an intrinsic orientation, a magnetic arrow built into the heart of the particle. This arrow can point in one of two directions, spin up or spin down. Here is the rule. Because the two electrons were born together with zero total spin, they must always cancel each other out. If one is spin up, the other must be spin down. They are a perfect pair, a yin and yang, of subatomic balance. This sounds simple enough. If you have a pair of gloves, and you put the right glove in a box, and the left glove in another box, you know that if you open one box and find the right glove, the other box must contain the left glove. There is no mystery there. The gloves were always right and left. They carried that identity with them from the moment they were separated. But remember the lesson of the double slit. Remember the ghost. In the quantum world, the gloves are not gloves. They are clouds of probability. Until you look at them, neither electron is spin up or spin down. They are both in a superposition. They are both spinning up and down at the same time. They are indefinite. They are hazy. Now, let us separate them. We take one of these entangled electrons, let us call it particle A, and we keep it here on Earth, in a quiet laboratory in Switzerland. We take its twin, particle B, and we load it onto a starship. We fly particle B away from Earth. We fly it past the Moon, past Mars, past Pluto. We leave the solar system. We travel for years in the silence of the void until we reach the Andromeda galaxy, 2.5 million light-years away. So now we have a system that spans the intergalactic void. Particle A is on Earth. Particle B is in Andromeda. They are separated by a distance so vast that light itself takes millions of years to cross it. They are completely isolated from each other. Back on Earth, a scientist decides to measure particle A. She sets up her detector. She forces the ghost to reveal itself. She asks the question, "Are you up or down?" The universe pauses. The wave function collapses. The electron snaps into reality. Let us say it chooses spin up. Here is the magic. At that exact instant, not a second later, not a millisecond later, but instantaneously, particle B in the Andromeda galaxy snaps into spin down. It does not matter that no one has touched particle B. It does not matter that it is millions of light years away. It implies that particle B somehow knew that its twin had been measured on Earth. It knew that the game was up. It knew that the balance had to be preserved. And so, faster than the speed of light, faster than time, it adopted the opposite state to ensure the cosmic ledger remained balanced. This is the spooky action that troubled Einstein. In Einstein's universe, nothing can travel faster than the speed of light. Light is the cosmic speed limit. It is the absolute ceiling of causality. If the sun were to explode right now, we would not know about it for 8 minutes, because that is how long it takes for the light and the gravity to reach us. We are always 8 minutes in the past relative to the sun. Information takes time to travel. Influence takes time to travel. But entanglement laughs at the speed of light. If the connection is instantaneous, it means that space, the distance between Earth and Andromeda, does not matter to the particles. It is as if the space isn't even there. Einstein could not accept this. He argued that the universe must be local, meaning things can only affect their immediate surroundings. He believed that if the particles appeared to be communicating instantly, it was a trick. He proposed that they were like the gloves in the boxes. He said that particle A and particle B must have had a hidden plan all along. He called these hidden variables. He believed that inside the electron, written in some microscopic code we could not yet read, was a set of instructions. If anyone measures me, I will be spin up, and my brother will be spin down. If this were true, then no communication was traveling faster than light. The outcome was decided at birth, and we just didn't know it until we looked. It was a sensible argument. It saved the speed of light. It saved common sense. It made the universe feel safe and mechanical again. For decades, this debate was just philosophy. There was no way to tell the difference between hidden plans, the gloves, and spooky action, the quantum magic. The results looked the same to the observer. But then, in 1964, an Irish physicist named John Bell entered the story. Bell was a quiet, thoughtful man who worked at CERN. He was not satisfied with philosophy. He wanted to know the truth. He sat down and did the math. And he discovered something incredible. He found a mathematical limit, now known as Bell's inequality, that could prove, once and for all, whether Einstein was right or wrong. I will not burden you with the complex mathematics, but the essence is this. Bell realized that if the particles had hidden plans, there was a statistical limit to how often their spins would match up when measured from different angles. If the world was made of solid, distinct objects with pre-written instructions, the correlation between the twins could only be so strong. But if the world was quantum, if the particles were truly communicating across space, ghost to ghost, then the correlation would break that limit. It would be stronger than classical physics allowed. It was a testable question. It was a challenge to reality itself. It took time to build the technology. But in the 1980s, a French physicist named Alain Aspect finally ran the experiment with the necessary precision. He created entangled photons, separated them, and measured them, switching the angles of his detectors so fast that no signal traveling at the speed of light could possibly pass between the particles in time. The world waited. The spirit of Einstein waited. The results came in. Einstein was wrong. The correlations broke the limit. The hidden variables did not exist. The particles did not have a secret instruction manual inside them. They made their decision at the moment of measurement, and they made it together as one single entity across the gap of space. The universe is non-local. Let that feeling wash over you. The here and there that define our lives are not absolute. To an entangled system, Earth and Andromeda are the same place. Distance is a construct. Separation is a convenience for the macrocosmic mind, but it is not a fundamental truth of the foundation. What does this mean for the nature of reality? It suggests that, at the deepest level, the universe is not a collection of separate parts bumping into each other. It is a single, indivisible sheet. It is a hologram where every part contains the whole. Think of an iceberg. You see two peaks of ice sticking out of the water, separated by 100 feet of open ocean. They look like two separate islands of ice. But if you look beneath the surface, you see that they are connected. They are just the protrusions of a single, massive mountain of ice. If you push one peak, the other moves. Not because a signal traveled through the water, but because they are the same thing. Entanglement suggests that particles are the peaks of the iceberg. We see them as separate points in space, but beneath the surface of the visible reality, in a dimension we cannot perceive, they are joined. They are one geometry. And now, consider the history of our universe. 14 billion years ago, all the matter and energy that exists today, every atom in your body, every star in the sky, every photon of light, was crushed into a single point, the singularity. In that moment of infinite density, everything was in contact with everything else. Everything was entangled with everything else. Then came the Big Bang. The universe expanded. The particles flew apart. The galaxies formed. The stars ignited. The carbon and oxygen and nitrogen formed. You formed. But if quantum theory holds true, the entanglement that was forged in that first fire has never truly been broken. The atoms in your left hand are entangled with atoms in a star 1 billion light years away. The electrons in your heart are dancing in rhythm with electrons in the soil of a planet we will never visit. You are not an isolated observer standing on a lonely rock. You are a web. You are a node in a vast, shimmering network of connection that spans the entire cosmos. This is not New Age mysticism. This is the hard conclusion of our best physics. We are part of a wholeness that we have forgotten because our senses deceive us. Our eyes tell us, I am here and the tree is there. But the quantum equations whisper, you and the tree are ripples in the same field. There is a beautiful interpretation of quantum mechanics called Bohmian mechanics, named after David Bohm, a physicist who was deeply interested in the order of the universe. He proposed that there is an implicate order, a deeper level of reality, where everything is folded together like a drop of ink mixed into a jar of glycerin. When we see particles, we are seeing the explicate order, the ink being unfolded for a moment. But the connection remains in the fold. This helps explain the mystery of the spooky action. There is no signal traveling faster than light, because there is no distance to travel. In the implicate order, the two particles are right on top of each other. They never separated. This realization changes how we feel about loneliness. In a world of classical physics, loneliness is a physical fact. You are a separate object, cut off by empty space. But in a quantum universe, loneliness is impossible. You are touching the universe at every moment. You are woven into it. Scientists are now using this spooky action to build the future. We are building quantum computers, machines that use entangled particles to perform calculations that would take a normal computer millions of years. We are exploring quantum teleportation, not of people, but of information, transferring the state of one particle to another instantly across a city. We are learning to pluck the strings of this invisible web. But the philosophical weight is heavier than the technological one. If the universe is non-local, if separation is an illusion, then what is space? We usually think of space as a stage. It is the empty box where the drama of the universe happens. It is the distance between things. But if distance can be ignored by entangled particles, then space might not be a fundamental thing. Space might be something that emerges from entanglement. Imagine a puzzle. When the pieces are scattered on the table, there is no picture. There is no geometry to the image. But as you lock the pieces together, as you entangle them, the picture emerges. The spatial relationship between the bird and the tree in the puzzle is created by the connection of the pieces. Some modern physicists believe that space-time itself, the very fabric we walk on, is stitched together by quantum entanglement. They call this ER, EPR. It is an equation that suggests a wormhole in space. ER is the same thing as an entangled pair of particles, EPR. It suggests that gravity, the force that holds your feet to the ground, might be the result of the universe wanting to stay entangled. We are drifting into deep waters now. We are asking questions that we cannot yet fully answer. But the direction of the evidence is clear. The solid, separate, lonely world of the 19th century is gone. We live in a participatory universe. We live in a universe of infinite intimacy. As we lie here in the dark, think about the person you love. Think about the feeling of connection you have with them. Science used to tell you that this feeling was just a chemical trick in your brain. But now, quantum mechanics opens a door. It says, who knows if the atoms of your brains have interacted, if you have shared breath and space and time, you are entangled. There is a correlation between you that no distance can sever. The state of your mind and the state of their mind are part of a single wave function. We are not just dust in the wind. We are the wind itself, blowing through the structure of space-time, connected to the beginning and the end. But there is a catch. There is always a catch in the quantum world. We cannot use entanglement to send a text message faster than light. We cannot use it to send winning lottery numbers to the past. The rules of the universe forbid us from controlling the outcome. We can measure the spin, and we know the other spin instantly, but we cannot force our electron to be up so that the other one becomes down. The outcome is random. Nature protects her causality. She allows the connection, but she forbids the command. We can share a destiny, but we cannot send a letter. It is a connection of being, not of doing. This, too, feels like a lesson. We want to control. We want to push and pull and dominate the world. But the deepest connection in the universe is one of pure synchronization. It is about being in tune, not about being in charge. We have looked at the particle, the wave, and the thread that connects them. We have destroyed the idea of solidity, the idea of passivity, and now the idea of separation. The universe is becoming more fluid, more unified, and more mysterious with every step we take. But where does this all happen? What is the background for this dance? We keep talking about empty space. We talk about the void between the stars, the vacuum inside the atom. We assume that if we take away all the particles, all the light, and all the energy, we would be left with nothing. But the quantum revolution has one more surprise for us. It turns out that nothing is not empty. The vacuum is not a void. The emptiness is actually the fullest thing in the universe. In the next chapter, we will dive into the quantum vacuum. We will explore the sea of virtual particles that pops in and out of existence trillions of times a second. We will learn that you are constantly borrowing energy from the nothingness, and that the empty space in front of your eyes is actually a boiling, frothing ocean of infinite energy. Rest now. Feel the invisible threads extending from your body, connecting you to the room, to the earth, to the stars. You are anchored in the cosmos. You are held by the unseen hands of physics. You are never, ever alone. Have you ever tried to imagine nothing? Close your eyes for a moment. Try to picture a space where absolutely nothing exists. No light, no sound, no air, no dust. Remove every atom. Remove every stray photon of radiation. Remove the magnetic fields. Remove the heat. Cool this imaginary box down to absolute zero, the temperature where all motion is supposed to stop. Now look at that empty, frozen blackness. What is left? Common sense tells you that you are looking at a void, a perfect, silent stage where nothing is happening. We believe that emptiness is the absence of things. We believe that if we take away the furniture of the universe, we are left with a blank room. But once again, the universe smiles at our simplicity. Welcome to the 4th chapter of our descent into the unknown. We have explored the ghost-like nature of matter, the duality of the wave, and the invisible web of entanglement. Now, we dive into the background of it all. We are going to look at the canvas itself, and we will discover that the canvas is not blank. The void is a lie. The emptiness is heavy. The silence is actually a scream of infinite energy. This is the story of the quantum vacuum. To understand why nothing is impossible, we have to return to the rules of the quantum game. There is a law written by Werner Heisenberg that governs everything in the subatomic realm. It is called the uncertainty principle. Usually we hear about this in terms of position and speed. You cannot know where a particle is and how fast it is moving at the same time. But there is another version of this law, one that relates energy and time. The law states that you cannot know the precise amount of energy in a system for a precise amount of time. There is a fuzziness, a trade-off. The shorter the time interval you look at, the more uncertain the energy becomes. This sounds like a technicality, but it has a shattering consequence for empty space. If you try to look at a tiny patch of empty space for a tiny fraction of a second, the energy in that space cannot be exactly zero. Zero is a precise number. Zero is perfect, and nature forbids perfection. Nature forbids zero. So, to avoid being zero, the universe does something magical. It cheats. It borrows energy from nowhere. In the deepest silence of the vacuum, pairs of particles spontaneously pop into existence. A particle of matter and a particle of antimatter, an electron and a positron, for example, emerge from the void. They borrow the energy to exist. They fly apart for a fleeting instant. And then they snap back together and annihilate each other, returning the energy to the bank. They are called virtual particles. But the word virtual is misleading. It makes them sound fake, like a computer simulation. They are not fake. They are very, very real, but they are transient. They live on borrowed time. They are ghosts that flicker in and out of reality trillion of times a second. Imagine the surface of a pot of boiling water. From a distance it might look smooth, but if you put your face right up to the water, you see bubbles rising and bursting, a chaotic churning of liquid and steam. Space is like that water. The empty space between your eyes and this screen is a seething, boiling froth of quantum foam. Particles are appearing and disappearing. Fields are fluctuating. Energy is vibrating. You are not walking through an empty room. You are walking through a dense medium. You are swimming in an ocean of infinite potential. But how do we know this is true? How do we know this isn't just a mathematical fantasy dreamed up by physicists with too much coffee? We know because we can feel the pressure of the ghosts. In 1948, a Dutch physicist named Hendrik Casemir proposed an experiment to prove that the vacuum has power. He said, take two metal plates, perfectly flat, perfectly polished mirrors. Place them in a vacuum, parallel to each other, and bring them very, very close together, micrometers apart. If the space between them is truly empty, nothing should happen. They should just hang there. But Casimir realized that the vacuum is filled with waves of virtual particles, waves of all sizes, big waves, small waves, tiny waves. Outside the plates, in the vast open space, all sizes of waves can fit. The ocean is wild and unrestricted, but between the plates, the space is tight. Only the small waves, the ones that fit in the gap, can exist there. The big waves are excluded. This creates an imbalance. There are more waves pushing on the outside of the plates than there are pushing from the inside. The pressure of the infinite vacuum outside is stronger than the pressure of the limited vacuum inside. The result? The plates are pushed together. They are crushed by the force of nothingness. When we finally performed this experiment in the laboratory, it worked exactly as predicted. The plates moved, The force was real. We measured the weight of the void, and it was heavy. This is the Casemir effect. It is tactile proof that emptiness is a substance. It is proof that we are surrounded by a pressure we cannot feel simply because it is pushing on us from all sides equally, like the air pressure of the atmosphere. But this leads to a dizzying thought. If empty space is full of energy, how much energy is there? If you sum up the energy of all the virtual particles, all the fluctuations, all the quantum vibrations in a single cubic centimeter of empty space, the size of a sugar cube, the number you get is catastrophic. According to some calculations in quantum field theory, the energy contained in the vacuum inside your coffee cup is enough to boil all the oceans on Earth. In fact, it might be enough to vaporize the entire galaxy. This is known as the vacuum catastrophe. It is one of the biggest unsolved mysteries in physics. Our theories tell us the vacuum should be infinitely heavy, dense with energy. Yet, we walk through it easily. Gravity doesn't seem to notice this massive weight. If the vacuum were truly that heavy, the universe would have collapsed into a black hole instantly. So, there is a mismatch, a huge one. But the fact remains, the energy is there in some form. We are fish swimming in deep water, unaware of the weight of the ocean above us, because we are built to withstand it. We are made of the same fields that constitute the vacuum. We are just excitations, knots of energy tied in the fabric of this ocean. Think about what this means for your own existence. We often feel empty inside. We feel a spiritual void, a lack of meaning, a silence where we want noise. But physically, there is no such thing as emptiness within you. Every atom in your body is 99% space, yes. But that space is alive. The vacuum inside your chest is glowing with invisible activity. The space inside your skull is a fireworks display of creation and destruction. You are not a shell. You are a dense, vibrant continuity with the cosmos. The nothing inside you is the same as the nothing between the stars. And it is the most potent stuff in the universe. This quantum vacuum is also the source of mass for most of the particles in the universe. You might have heard of the Higgs field. This is a field that permeates all of space, like a cosmic molasses. As particles move through it, they feel resistance. That resistance is what we call mass. If the Higgs field disappeared tomorrow, your electrons would suddenly become weightless. They would fly away at the speed of light. Your atoms would disintegrate. You would vanish in a flash of pure radiation. You exist as a solid being only because you are constantly interacting with the invisible fields that fill the vacuum. You are being held together by the nothing. And this brings us to an ancient idea. The mystics of the past, from the Taoists to the Buddhists, often spoke of the void or the plenum. They said that form is emptiness, and emptiness is form. They claimed that the universe emerges from a background of silence that is actually full of potential. Quantum physics has arrived at the same mountain peak, but from a different path. We have found that the foundation of reality is a restless, jittery, creative silence. This zero-point energy, the minimum energy of the vacuum, means that the universe can never truly be still. Absolute rest is impossible. Even at the coldest temperature, even in the deepest death of the heat death of the universe, the fields will still be quivering. Life, in the sense of movement and vibration, is baked into the fundamental laws. The universe cannot die completely. It can only sleep. And even in its sleep, it dreams of particles. But there is a darker side to the vacuum. If particles can pop out of nothing, could a whole universe pop out of nothing? Some cosmologists believe that the Big Bang itself was just a quantum fluctuation, a rare, random bubble of energy that appeared in a pre-existing vacuum. We might be just a large virtual particle that hasn't annihilated yet. We might be a momentary flash in a much larger, older void. And if it happened once, it can happen again. There is a theory called false vacuum decay. It suggests that the vacuum we live in might not be the true lowest energy state. We might be living on a ledge, thinking we are on the ground floor. If a tiny bubble of true vacuum were to appear anywhere in the universe, it would expand at the speed of light. It would rewrite the laws of physics. It would destroy everything in its path instantly, without warning. It sounds terrifying, but in the context of our journey, it is just another reminder of our fragility. We are fragile structures floating on a deep, powerful sea. We do not control the ocean. We ride the waves. As we float here, contemplating the fullness of the void, we must ask ourselves, if the vacuum is generating possibilities, if particles are constantly making choices, popping in and out, taking left paths and right paths, what happens to the paths not taken? Remember the electron in the double-slit experiment? It went through both slits. It was in a superposition. But eventually, we saw it in one place. What happened to the version of the electron that was in the other place? Did it just vanish? Did the universe delete that timeline? Or is the universe even bigger than we thought? Is it possible that every time a quantum event happens, every time a choice is made, the universe does not choose one outcome? Maybe it chooses all of them. In the next chapter, we will leave the vacuum and enter the multiverse. We will explore the many worlds interpretation of quantum mechanics. We will ask the question, is there another version of you reading this script right now, but in a world where you made different choices? Are there infinite yous living infinite lives in infinite parallel realities? The vacuum is full of energy, but the multiverse is full of destinies. Rest now in the fullness of the empty space. Feel the air against your skin and know that even the space between the air molecules is touching you with a billion tiny ghost fingers. You are supported. You are surrounded. You are never truly in the dark. Think back to this morning. You stood in your kitchen, perhaps looking at the kettle or the coffee maker. You made a choice. Maybe you chose tea. It was a trivial decision, a momentary flicker of neurons firing in your brain, leading to a hand reaching for a tea bag instead of coffee beans. You drank the tea. The day moved on. The moment is gone, hardened into the cement of the past. In your memory, there is only one history. You are the person who drank tea. The version of you who drank coffee does not exist. That path was not taken, so it vanished into the ether of what might have been. We live our lives as a single, thin line drawn through time, discarding possibilities at every turn like shedding skin. We carry the weight of our choices, the burden of our what-ifs, believing that for every door we open, 1,000 others slam shut forever. But what if the doors never close? Welcome to the 5th chapter of our journey. We have stood on the edge of the abyss where particles dissolve into waves. We have seen ghosts that communicate instantly across galaxies. We have felt the pressure of the boiling vacuum. Now, we must confront the most vertigo-inducing possibility of all. We are going to challenge the uniqueness of your life. We are going to explore the many worlds interpretation of quantum mechanics. This story begins with a cat, a very famous, very unfortunate, purely imaginary cat. In 1935, the Austrian physicist Erwin Schrodinger was struggling with the absurdity of the quantum world. He wanted to show just how ridiculous it was to claim that particles could be in a superposition, two states at once. until observed. So, he designed a thought experiment. Imagine a sealed steel box. Inside the box, we place a cat. Along with the cat, we place a diabolical device. There is a tiny bit of radioactive substance, so small that in the course of an hour, there is a 50% chance that one atom will decay and a 50% chance that it will not. If the atom decays, it triggers a Geiger counter, which releases a hammer, which shatters a vial of poison, which kills the cat. We seal the box. We wait an hour. According to the rules of quantum mechanics, the radioactive atom enters a superposition. It is both decayed and not decayed at the same time. It is a wave of both possibilities. But here is the problem. The atom is linked to the Geiger counter, which is linked to the hammer, which is linked to the poison, which is linked to the cat. Because they are all entangled, the state of the atom spreads to the entire system. Until you open the box, quantum mechanics says the cat is in a superposition. It is not dead. It is not alive. It is dead and alive. It is a blur of two mutually exclusive realities existing in the same space. Schrodinger thought this was nonsense. He meant it as a joke, a reductio ad absurdum. Obviously, a cat cannot be dead and alive. When we look, we will see one or the other. Therefore, he argued, there must be something wrong with our understanding of superposition. The universe must choose long before we open the lid. But the math refused to agree. The equations insisted the superposition was real. For decades, physicists accepted the Copenhagen interpretation, which we discussed in Chapter 2. They said, when you open the box, your observation forces the wave function to collapse. The universe chooses one outcome, dead or alive, and the other possibility vanishes instantly. But in 1957, a brilliant young graduate student named Hugh Everett Thornton asked a simple, dangerous question. What if the wave never collapses? What if the universe never chooses? Everett looked at the math, and he saw no mechanism for the collapse. The equations of quantum mechanics are linear and continuous. They do not snap, they flow. So, Everett proposed a radical alternative. He suggested that when you open the box, you do not force the cat to become alive or dead. Instead, you become entangled with the cat. The wave function does not shrink, it grows. It expands to include you. In that moment of observation, the universe splits. The timeline forks like a crack in the ice. In one branch of reality, you open the box, you see a living cat, and you feel relief. You carry on with your day, remembering a living cat. In another, equally real branch of reality, you open the box, you see a dead cat, and you feel sadness. You carry on with your day, remembering a dead cat. Both versions of you exist. Both versions are real. Both versions believe they are the only version, but they are separated by a wall of decoherence. They can no longer see each other. They can no longer communicate. They have drifted apart into separate dimensions of a vast, infinite Hilbert space. This is the many worlds interpretation. And if it is true, the implications for your life are shattering. It means that every time a quantum event happens, which is trillions of times a second in every atom of your body, the universe branches. The coin toss does not land on heads or tails. It lands on heads and tails in two different worlds. Think back to that cup of tea. In this world, you drank tea, but in another branch, the neurons in your brain fired slightly differently. A quantum event shifted the chemical cascade, and you drank coffee. In that world, perhaps the caffeine made you slightly more jittery. Maybe you left the house 2 minutes earlier. Maybe, because of those 2 minutes, you missed a bus. Or you caught a bus. or you met someone you would not have met. The branches diverge. Over years, over decades, the differences compound. There is a world where you took that job in the other city. There is a world where you married your high school sweetheart. There is a world where you did not say the angry words that ended a friendship. There is a world where you turned left instead of right and avoided the accident. And there is a world where you did not. This view of reality is dizzying. It creates a multiverse, not of distant bubble universes floating in a void, but of parallel realities occupying the same space, superimposed but invisible to each other, like 1,000 radio stations playing in the same room at the same time. You only hear the station you're tuned to. You only see the slice of reality that constitutes your branch. But the other songs are still playing. Everett's idea was ignored for a long time. It was too weird. It was too heavy. It violated our sense of uniqueness. We want to be the protagonist of the story. We want our choices to matter because they reject the alternatives. If all alternatives happen, does any choice matter? If I am both a hero and a villain in the multiverse, who am I really? But modern physics has slowly warmed to this idea. Why? Because it solves the paradox of the observer. It removes the need for a mystical collapse triggered by consciousness. It restores the elegance of the math. It says the universe is deterministic and complete. It creates everything that can be created. It also changes how we relate to regret. We all carry ghosts of regret. I should have done this. I wish I hadn't said that. We look at our mistakes and we feel the sting of the irrevocable. But in the many worlds, there is no such thing as what might have been. It is what is somewhere else. The version of you that made the right choice exists. They are happy. They are living that life. And in a strange way, they are still you. They share your past, your childhood, your memories up until the moment of the split. They are your brother, your sister, your shadow self. Does this diminish your current life, or does it expand it? There is a profound humility in this perspective. It suggests that we are not a single melody. We are a symphony. We are a chorus of infinite selves, exploring every nook and cranny of possibility. The you that is here, right now, reading these words, is just one note in that chord. You are the witness of this specific path. Your job is not to regret the other paths, but to experience this one fully. The other versions of you are taking care of the other paths. They are carrying the burdens you didn't pick up. They are enjoying the rewards you didn't receive. But there is a darker, stranger edge to this theory. It is called quantum immortality. Imagine the Schrodinger's cat experiment again. But this time, imagine you are the cat. You are inside the box. The atom decays or doesn't. The poison is released or isn't. The universe splits. In World A, you die. Your consciousness ends. The screen goes black. In World B, you survive. You hear the click, but the poison fails. You live. Here is the chilling thought. You can only experience the world in which you survive. You cannot experience non-existence. So, from your subjective perspective, you will always find yourself in the branch where the hammer missed, or the gun jammed, or the car swerved just in time. As the branches split and split again, there will always be a thin sliver of probability where you continue to exist. And that is the only path your consciousness can follow. To the outside observer, you might die. But to yourself, you might seem miraculously lucky, surviving against all odds. Again and again. This is highly speculative. It assumes consciousness cannot end. But it is a haunting whisper in the corridors of quantum philosophy. Are we trapped in existence? Are we forced to ride the wave of survival until the very end of time? We do not know. The many worlds interpretation is just that, an interpretation. We cannot call the other worlds on the phone. We cannot cross the barrier. The decoherence is absolute. Once the glass shatters, it cannot be unshattered. Or can it? Some physicists are asking if we might be able to detect the gravity of these other worlds. If there are infinite parallel Earths, do they weigh anything? Could the dark matter we talked about in previous chapters actually be the gravitational shadow of our neighbors in the multiverse? Are we feeling the pull of the ghosts next door? It is a fringe idea, but it shows how desperate we are to touch the invisible. Let us return to the room you are sitting in. Look at the shadows in the corner. In another branch, the light is on. In another branch, someone is sitting there with you. In another branch, the room is empty because you decided to go for a walk. The space around you is crowded with these invisible realities. They are vibrating through you. This realization creates a strange feeling of solidarity. If every tragedy that could happen to you has happened to another version of you, then you are the lucky one in this moment. You are the survivor of 1 billion invisible disasters. The fact that you are here, safe, breathing, reading, is a statistical miracle. You are surfing on the crest of a wave of survival that has crashed and broken in 1 trillion other places. Be gentle with yourself. Be gentle with your mistakes. In the grand calculus of the multiverse, every mistake led to a lesson, and every error led to a new direction. You are doing the work of existence just by being here. But if all of these worlds exist, if all of time is branching out like a fractal tree, what is time itself? We feel time as a river. It flows from the past to the future. We remember the past, but we do not remember the future. We can break an egg, but we cannot unbreak it. We age, we do not grow younger. Why? In the fundamental equations of physics, in the math of Newton, of Einstein, of Schrodinger, there is no arrow of time. The equations work perfectly well backwards. A movie of a planet orbiting a star looks fine if you play it in reverse. A video of 2 billiard balls colliding makes sense in reverse. So why does our life only move one way? Why is the future a mystery and the past a fact? If we live in a quantum universe of reversibility and symmetry, where does the arrow of time come from? Is it possible that time is an illusion created by our perspective? Is it possible that the past, present, and future all exist simultaneously, frozen in a vast block of now? In the next chapter, we will confront the mystery of entropy and the illusion of time. We will ask why we cannot remember tomorrow. We will explore the idea that the universe is winding down and that our sensation of flowing through life is just the heat of the burning fuse. Rest now in the multitude. Close your eyes and feel the presence of your infinite selves, radiating out from this moment like rays from a star. You are not a line. You are a sphere of possibilities. You are vast. Imagine you are watching a movie of your life, but playing in reverse. You see yourself walking backwards out of a room. You see the steam from your coffee rushing back into the cup, swirling from chaos into a perfect, hot spiral. You see a broken vase on the floor leaping upward, the shards knitting themselves together in midair, sealing the cracks, and landing gently, perfectly whole, on the table. It looks magical. It looks impossible. It makes you laugh because your intuition screams that the universe does not work that way. Things break. They do not unbreak. Heat spreads out. It does not gather. We grow old. We do not grow young. This one-way street is the most fundamental experience of your existence. It is the river you are swimming in. We call it the arrow of time. But here is the secret that keeps physicists awake at night. Deep down, in the microscopic laws that govern reality, there is no river. There is no arrow. Welcome to the 6th chapter of our quiet exploration. We have dissolved the solid world, we have entangled the galaxy, and we have split the timeline. Now, we must face the ghost that haunts every second of your life. We must ask why the past is frozen and the future is open. We must ask why we are forced to move forward, never backward. To understand this mystery, we must look at the equations. If you look at Newton's laws of motion, or Einstein's relativity, or Schrodinger's quantum mechanics, you will find something strange. They are all time-symmetric. This means that tt, time, is just a coordinate, like left or right. In the math, there is nothing that prevents a planet from orbiting backwards. There is nothing that prevents a billiard ball from retracing its path. If you could zoom in on a single collision between two atoms, and you played the video backward, it would look perfectly natural. The laws of physics allow it. So, if the atoms that make up your body can move backward in time just as easily as forward, why can't you? Why can't the vase unbreak? The answer lies not in the particles themselves, but in the crowd. It lies in the concept of entropy. In the 19th century, an Austrian physicist named Ludwig Boltzmann looked at the world and saw a game of statistics. He realized that order is rare and disorder is common. Think of a deck of cards. There is only one way to have the cards perfectly ordered, ace to king by suit. That is a low entropy state. It is special. It is organized. But there are 8, followed by 67 zeros ways to have the cards mixed up. That is high entropy. If you throw a sorted deck of cards into the air, what happens? They scatter. They mix. When you pick them up, they will be disordered. Not because a force pushed them into disorder, but simply because there are trillions more ways to be messy than to be tidy. The universe is that deck of cards. It is constantly being thrown into the air. This is the second law of thermodynamics. It states that in a closed system, entropy, the measure of disorder, always increases. Things tend to fall apart. Energy tends to spread out. The vase breaks because there are millions of arrangements of shards that look like broken vase, but only one arrangement that looks like whole vase. The universe moves toward the state of highest probability. So, time is not a force. Time is a statistic. The feeling of forward is just the feeling of things getting messier. But this leads to a profound question. If the universe is always getting messier, that means yesterday it was tidier. And the day before that, it was even tidier. If you wind the clock back all the way 13.8 billion years ago, you arrive at the Big Bang. For the arrow of time to exist, the Big Bang must have been a moment of incredibly, impossibly low entropy. It must have been the most organized, perfectly ordered state imaginable. A state of pure, condensed potential. Why? Why did the universe start in such a pristine state? We do not know. It is one of the deepest mysteries of cosmology. Roger Penrose, a Nobel laureate, calculated the odds of our universe starting in such a low entropy state by chance. The number is 10 to the power of 10 to the power of 123. It is a number so big that if you wrote a 0 on every particle in the universe, you would not have enough room to write it down. We are living in the aftershock of that singular miracle of order. We are riding the explosion of complexity as it unwinds into the void. But let us go deeper. What is now? You feel that you exist in the present moment. The past is a memory. The future is a fog. You feel that now is a spotlight moving along the timeline, illuminating 1 second at a time. This is called presentism, but Einstein had a different view. When his best friend, Michel Besso, died, Einstein wrote a letter to Besso's family. He said, "Now he has departed from this strange world a little ahead of me. That means nothing. People like us, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein believed in the block universe. Imagine a loaf of bread. The whole loaf exists at once. You can slice it anywhere you want. In this view, the universe is a four-dimensional block. Space and time are welded together. Every moment that has ever happened and every moment that will ever happen exists simultaneously in the block. The dinosaurs are still roaming the earth in their slice of the block. You are being born in your slice. You are reading this sentence in this slice. And you are dying in a slice further down the loaf. All of them are equally real. All of them are now, to the observer, trapped in that slice. There is no moving spotlight. There is no flow. The entire history of the cosmos is a frozen sculpture of space-time. Why then do we feel the flow? Why does it feel like we are moving? It comes back to the brain and entropy. Your brain is a machine that consumes energy to create order, memories, while creating disorder, heat, in the surroundings. You eat food, ordered energy, and you radiate heat, disordered energy. This process creates a chemical gradient in your neurons. Memories are just physical traces left by the past. A footprint in the sand is a memory of a foot. A crater is a memory of a meteor. These traces only form in the direction of increasing entropy. You cannot have a footprint of a foot that hasn't stepped yet. The laws of thermodynamics forbid it. So, your brain is wired to only have access to one direction of the block. You have data from the past direction and zero data from the future direction. This asymmetry creates the psychological sensation of moving forward. You are effectively crawling through the block universe, looking backward. This is a terrifying but also liberating thought. It means that the loss we feel when a moment passes is an illusion. The moment did not vanish. It is still there, fixed in the amber of space-time forever. The child you were is still playing in the garden. The loved one you lost is still holding your hand in the section of the block where you were together. Nothing is ever truly erased. But let us look at the far end of the loaf. Where is this entropy taking us? If disorder always increases, eventually, the universe will reach a maximum state of disorder. The stars will burn out. The black holes will evaporate. The particles will spread out so far that they never touch again. The temperature will drop to near absolute zero everywhere. This is the heat death of the universe, the big freeze. It sounds bleak. It sounds like the ultimate tragedy. But in the context of our contemplative journey, it is just the final exhaling of the breath that began at the Big Bang. It is the return to equilibrium. The silence at the end of the song is what gives the song its shape. And there is a strange loophole. Remember the quantum vacuum? Remember the Boltzmann brains? If you wait long enough in the heat death, trillions upon trillions of years, the random fluctuations of the vacuum might, just by pure chance, assemble a structure. Given infinite time, a fluctuation could assemble a hydrogen atom, or a star, or a brain. Ludwig Boltzmann realized that if the universe lasts forever, it is statistically possible for a fully formed brain, complete with false memories of a past life, to pop out of the chaos for a second and then dissolve back into the void. This is the Boltzmann brain paradox. It asks, Are you a real person living a continuous life? Or did you just pop into existence 1 second ago with all your memories of reading the last 5 chapters implanted by a random quantum fluctuation? You cannot prove you aren't. But let us step back from the edge of madness. Let us return to the feeling of the river. The illusion of time is the medium of our growth. We need the sequence. We need the cause and effect to tell stories, to learn, to love. A melody is only beautiful because the notes happen one after another. If you played all the notes of a symphony at once, it would just be a noisy crash. Time spreads the music out so we can hear it. We are creatures of the transition. We live in the sweet spot between the perfect order of the Big Bang and the perfect chaos of the heat death. We live in the Goldilocks zone of entropy, where there is enough structure to build cells and cities, but enough freedom to change and evolve. We are the burning fuse. The flame of consciousness can only exist where the fuel of the future is being consumed into the ash of the past. You are the process of entropy becoming aware of itself. This gives a new meaning to the present moment. If the past is a memory and the future is a guess, then the now is the only place where the burning happens. It is the only place where you touch reality. Zen masters and mystics have said this for millennia. Be here now. Physics tells us why. Because here and now is the cutting edge of the block universe. It is the wavefront of the decoherence. As we move to the next chapter, we are going to look at what happens when this fabric of space-time gets twisted. We have talked about time flowing, but what if time can bend? What if it can stop? We are going to approach the monsters of the cosmos, the black holes. In the heart of a black hole, the rules of time and space we have discussed are crushed out of existence. Time stops, space falls inward, and the entropy we talked about, it gets trapped on the surface, on the event horizon. We will explore the holographic principle, the idea that our entire three-dimensional universe might just be a projection, a hologram painted on the edge of a cosmic horizon. Rest now in the flow. Do not fight the current. The river of time is carrying you, but you are also the water. You are the stillness inside the motion. The moments you have lived are yours forever, written in the block of eternity, unchangeable and safe. Have you ever felt the heaviness of your own body? When you lie in bed at night, exhausted, you feel the mattress pressing up against you. You feel gravity as a persistent, gentle hand pulling you toward the center of the earth. We think of gravity as a force, a magnet that grabs us and holds us down. But Albert Einstein taught us to see it differently. He taught us that gravity is not a pull, it is a curve. The earth is heavy, and its mass bends the fabric of space and time around it, creating a valley. You are not being pulled. You're simply sliding down the slope of that valley. You're falling toward the center, and the ground is the only thing stopping you. But what happens when the valley becomes a bottomless pit? What happens when the curve becomes so steep that the walls become vertical? Welcome to the 7th chapter of our descent. We have explored the quantum ghosts, the boiling vacuum, and the illusion of time. Now, we must travel to the places where the laws of physics break down completely. We are going to the graveyards of the stars. We are going to look into the eye of the black hole, and we will discover that these monsters might hold the secret to the ultimate nature of our reality, that everything you see, everything you touch, might be a hologram. Imagine a star, a massive, burning giant, 20 times the size of our sun. For millions of years, it fights a war against its own gravity. The nuclear fire in its core pushes out and gravity pulls in. It is a stalemate of titans. But eventually, the fuel runs out, the fire dies, and gravity wins. In a fraction of a second, the star collapses. The iron core implodes. The outer layers are blown away in a supernova, a majestic funeral pyre that outshines the galaxy. But in the center, the collapse does not stop. The matter is crushed smaller and smaller. It passes the density of rock, the density of lead, the density of an atomic nucleus. It keeps going. It shrinks to a point of zero size and infinite density. It becomes a singularity, a puncture in the fabric of space-time. Around this singularity, there is a boundary, a point of no return. We call it the event horizon. To understand the horror and the beauty of the event horizon, imagine a river flowing toward a waterfall. As you get closer to the edge, the water speeds up. If you're in a boat, you can row against the current and stay in place. But as you get closer to the drop, the current becomes faster. Eventually, you reach a point where the water is flowing faster than you can row. Even if you row at your maximum speed, you will still be dragged backward over the edge. Space is that river. A black hole drags space itself inward. At the event horizon, space is falling into the hole at the speed of light. Since nothing can travel faster than light, nothing can swim upstream past this point. Not a rocket, not a signal, not even a beam of light. Once you cross that line, there is no up anymore. All directions lead down. To try to escape would be like trying to go to yesterday. It is not a matter of power. It is a matter of geometry. The future is the singularity. But strange things happen to time near this edge. If you were to watch a friend fall into a black hole while you stayed safely far away, you would never see them cross the horizon. As they approach the edge, the light coming from them has to climb out of that steep gravitational valley. It loses energy. It gets stretched. You would see your friend slow down. Their movements would become sluggish, like a film running in slow motion. The light from their body would turn redder and dimmer. They would fade and freeze. To your eyes, they would remain plastered on the horizon forever, a ghostly, frozen image of their last moment, slowly fading to black. But from their perspective, looking out at the universe, time would speed up. They would see the entire future of the cosmos flash by in a fast-forward blur. They would see stars born and die in seconds. They are falling out of time. This separation of perspectives brings us to the great paradox, the information paradox. Stephen Hawking, the brilliant physicist who roamed the cosmos from his wheelchair, realized something disturbing. He discovered that black holes are not truly black. They radiate. Due to quantum fluctuations near the horizon, those virtual particles we talked about in Chapter 4, black holes slowly leak energy. Over trillions of years, they evaporate. They shrink and eventually disappear in a final pop of radiation. But what happens to the stuff that fell in? If you throw a book into a fire, the book is destroyed. But the information is not lost. The words are gone. But the atoms of the paper and ink are still there in the ash and the smoke. If you had a supercomputer and you collected every particle of smoke, you could, in theory, reconstruct the book. The information is scrambled, but it is preserved. Physics relies on this rule. Information is never lost. The past determines the future. But if you throw a book into a black hole, and the black hole eventually evaporates into pure, random radiation, where did the book go? The radiation coming out does not carry the pattern of the book. It is just random heat. When the black hole disappears, the information seems to be deleted from the universe entirely. This violates the fundamental laws of quantum mechanics. It created a war in the physics community that lasted for decades. The solution that eventually emerged is even stranger than the paradox. It suggests that our common sense about where things are is wrong. Enter the holographic principle. Think of a soup can. The soup is inside the can. It is a three-dimensional volume of vegetables and broth. But where is the information about the soup? It is on the label. The label is a two-dimensional sheet wrapped around the can. It tells you the ingredients, the calories, the brand. You can learn everything about the 3D soup by reading the 2D label. Physicists Leonard Susskind and Gerard T. Hooft proposed that a black hole is like that soup can. They suggested that when an object falls into a black hole, its physical body is crushed, but its information, the pattern of its atoms, its quantum state, gets smeared out across the event horizon. It gets plastered onto the surface like a sticker. The event horizon becomes a vast library, a two-dimensional shell covered in scrambled data. This solved the paradox. When the black hole radiates, it picks up the information from the surface and carries it back out into the universe, like the wind picking up dust. The information is not lost. It is just stored on the shell. But here is the twist that makes the ground beneath your feet dissolve. If the laws of physics allow a 3D object, a star, a book, a person, to be perfectly described by 2D data on a surface, could this apply to the whole universe? We are inside a universe that has a horizon, the edge of the observable cosmos. Could it be that everything we experience, the depth of the room, the volume of your body, the vastness of space, is just a projection? The holographic principle suggests that the reality we inhabit might be a 3D hologram generated by a 2D surface of data located at the boundary of the universe. Imagine you are playing a video game. You see a 3D world on your screen. You see mountains, characters, depth. You can walk forward and backward. But where is that world really? It is on a 2D microchip. It is a stream of zeros and ones processed by a computer. The depth is an illusion created by the processing of information. We might be the characters on the screen. The real you, the fundamental data that describes you, might be smeared on the cosmic horizon billions of light years away, encoded in Planck-sized bits of information. And your experience of sitting here, reading this, feeling the weight of gravity, is the projection. You are the hologram. This does not mean you are fake. A hologram is real. It is just structured differently than we thought. It means that space is not a fundamental container. Space is a result of the information processing. This idea connects beautifully with what we learned about entanglement. Remember how entangled particles ignore distance? In a holographic universe, this makes perfect sense. On the 2D surface, the data for particle A and particle B might be sitting right next to each other. They are touching. But in the 3D projection, they appear to be millions of miles apart. The spooky action is just the projection behaving according to the source code. We are navigating a universe of deep codes. There is a team of physicists right now looking for pixelation in the fabric of space. If we are a hologram, there should be a limit to how small things can get. There should be a resolution to the universe, like the pixels on a TV screen. This is the Planck length. If we find this graininess, it would be strong evidence that we are indeed living in a projected reality. How does this make you feel? For some, it is terrifying. It feels like a loss of substance. But for others, It is liberating. It suggests that we are information, we are patterns, and patterns are resilient. It also changes our view of death. If we are information, then death is just the scrambling of the code. The bits return to the cosmos. The pattern dissolves. But the substance of the information, the energy, the quantum states, remains written on the horizon of eternity. And think about the black hole again. We used to think of it as a destroyer, a cosmic drain. But in this new light, a black hole is the ultimate hard drive. It is the most efficient storage device in nature. It packs the maximum amount of information into the minimum amount of space. Perhaps the universe is not a collection of rocks and gas, but a collection of memories. A vast computing ocean of data calculating itself into existence. The monsters of the dark, the black holes, are actually the archives. They are the keepers of the lost books. As we lie here, feeling the gravity that mimics the black hole's pull, we can sense the connection. Gravity is the force that connects the hologram. It is the geometry of the projection. But if the visible matter, the stars, the planets, the gas, the black holes, is only a tiny fraction of the universe, what is the rest? When we look at the rotation of galaxies, they spin too fast. They should fly apart. There is not enough visible gravity to hold them together. And when we look at the expansion of the universe, it is accelerating. Something is pushing it apart. We have explored the visible ghosts. Now we must face the invisible giants. In the next chapter, we will venture into the darkness that makes up 95% of our reality. We will talk about dark matter and dark energy. We will discover that the universe we can see is just the foam on top of a dark, invisible ocean. We are the minority. The real universe is a shadow world that passes right through us, silent and unseen. Rest now in your holographic form. You are a projection of light and data, a sophisticated image singing in the void. You are written on the sky. Imagine walking through a dense forest at night. You have a flashlight, and its beam cuts a narrow cone through the darkness. You see the trunks of trees, the flash of leaves, perhaps the eyes of an owl reflecting the light. You construct your reality based on what the light touches. You believe the forest consists of the things you can see. But if you turn off the light and stand in the absolute blackness, you feel the wind on your face. You hear the rustling of branches. You feel the ground beneath your boots. You realize that the things you saw with your light were only a tiny fraction of the forest. The true forest is the darkness itself. It is the vast, unseen bulk that surrounds you, holds you, and breathes around you. Welcome to the 8th chapter of our journey into the invisible. We have dissolved the atom, touched the quantum web, and stood on the edge of the black hole. Now, we must confront the most humbling fact of all. We must admit that everything we have explored so far, the stars, the planets, the gas clouds, the light, you, me, the atoms, the quarks, all of it is just the foam on top of a deep, dark ocean. We are the minority. We are the glowing dust floating in a universe made of shadows. This is the story of the invisible giants, dark matter and dark energy. For centuries, astronomers looked up at the sky and assumed that what they saw was what existed. They counted the stars. They measured the light. They believed that gravity was generated by the visible matter, the burning suns, and the swirling gas. It was a logical assumption. Light equals stuff. Darkness equals empty space. But in the 1970s, an astronomer named Vera Rubin changed everything. She was studying the rotation of spiral galaxies, those beautiful pinwheels of light that look like our own Milky Way. She was measuring how fast the stars on the edge of the galaxy were orbiting compared to the stars in the center. According to the laws of Newton and Einstein, the stars on the edge should be moving slower than the stars in the center, just like Pluto moves slower than Mercury. The gravity is weaker at the edge, so the speed should drop. But when Rubin looked at the data, she saw something impossible. The stars on the edge were moving just as fast as the stars in the center. In fact, they were moving so fast that they should have been flung out into deep space. The visible gravity of the galaxy was nowhere near strong enough to hold onto them at those speeds. It was as if you were spinning a merry-go-round at 100 miles an hour, and the children on the edge were holding on with one finger, yet not flying off. Something else had to be holding them. Something invisible. Something massive. Rubin realized that for the galaxy to hold together, it must be embedded in a vast, invisible cloud of matter, a halo of darkness that extended far beyond the visible stars. This invisible stuff provided the extra gravity needed to keep the stars in their orbits. We called it dark matter, but the name is a placeholder. It is not dark like a shadow. Shadows are caused by blocked light. This matter is transparent. It does not emit light. It does not reflect light. It does not block light. It is a ghost. It passes right through normal matter as if it were not there. Right now, as you sit here, billions of dark matter particles are streaming through your body. They are passing through the roof, through your skin, through the earth, and out the other side, without hitting a single atom. They are weakly interacting massive particles, WIMPs, interacting only through gravity. We know they are there because we see their fingerprints. We see light from distant galaxies bending around invisible clumps in space. We see the structure of the cosmic web, the filaments of galaxies, tracing the skeleton of dark matter. But here is the scale of the ghost. In a typical galaxy like the Milky Way, dark matter accounts for about 90% of the total mass. The beautiful spiral arms, the bright nebulas, the billions of stars, that is just the 10% decoration. The galaxy is really a ball of dark matter with a little bit of glowing grit in the middle. We are the grit. This realization is a blow to our ego, but it gets worse. Or perhaps it gets more magnificent, because while dark matter pulls things together, there is another force pushing things apart. In 1998, 2 teams of astronomers were looking at distant supernovas, exploding stars, to measure the expansion of the universe. We knew the universe had been expanding since the Big Bang, but we assumed that gravity, the great attractor, was slowing it down. We assumed the universe was like a ball thrown into the air. It goes up, but eventually gravity slows it down and pulls it back. The astronomers expected to see the expansion decelerating. Instead, they found the opposite. The universe is speeding up. The distant galaxies are rushing away from us faster today than they were yesterday. The ball thrown into the air is not slowing down. It is strapping on a rocket engine and shooting into the stars. Something is pushing space apart. Something is counteracting gravity. Something is creating more space between the galaxies, stretching the fabric of the cosmos faster and faster. We called it dark energy, and this force is even more mysterious than dark matter. We do not know what it is. It might be a property of space itself, a cosmological constant that Einstein once proposed. It might be a new field, a quintessence, that permeates the universe. All we know is that it acts as a kind of anti-gravity, and it is winning. When we tally up the energy budget of the entire universe, the numbers are staggering. Visible matter, the atoms, the stars, the gas, the people, the books, makes up about 5% of the universe. Dark matter makes up about 27%, and dark energy makes up about 68%. Look at your hand again. Look at the room. Look at the world. Everything you have ever seen, touched, or loved is part of that tiny 5% sliver. The other 95% of reality is a dark, silent ocean that we cannot see and barely understand. We are living in a universe that is almost entirely unknown to us. We are the anomaly. The normal state of the universe is darkness. This leads us to a profound sense of isolation, but also a strange kind of intimacy with the void. The dark energy is not just out there between the galaxies. It is everywhere. It is in the room with you. It is in the space between your eyes and the screen. It is weak on small scales, overpowered by the gravity of Earth and the electrical forces of your atoms. But it is there, quietly pushing, waiting for the scales to tip. As the universe ages, dark energy becomes stronger relative to gravity. Gravity gets weaker as things spread out, but dark energy does not dilute. It is a property of space, so more space means more dark energy. This dictates the future of our home. Because of this accelerating expansion, the universe is destined to become a lonely place. Billions of years from now, the distant galaxies will be pushed away so fast that their light can no longer reach us. They will slip behind the cosmic horizon. One by one, the galaxies will wink out. The night sky will empty. If there are astronomers alive in the distant future, they will look up and see only their own galaxy, floating in an endless, ink-black void. They might conclude that they are the only galaxy in existence. The evidence of the Big Bang, the evidence of the cosmic web, will have been erased by the expansion. We are living in a privileged moment. We are living in the brief era when the universe is still connected, when the light can still traverse the dark ocean. We can see the history. We can see the neighbors. But there is a question that arises from this darkness, a question that brings us back to the mystery of our own existence. If the universe is mostly dark matter and dark energy, and if the expansion is tearing it apart, and if the laws of physics are so precise, why are we here? Why is the universe capable of producing life at all? This is the mystery of fine-tuning. If you were to change the strength of dark energy by a tiny fraction, if you made it slightly stronger, the universe would have ripped itself apart before the first star could form. Atoms would never have coalesced. If you made it slightly weaker, the universe would have collapsed back into a big crunch milliseconds after the Big Bang. The same is true for the mass of the electron, the strength of the nuclear forces, the ratio of dark matter to normal matter. The dials of the universe seem to be set with terrifying precision to a specific combination that allows for complexity. Is this luck? Is it a coincidence? Or is it a selection? Remember the multiverse we discussed in Chapter 5? The idea of infinite bubbles, infinite variations. If there are infinite universes, then most of them are dead. Most of them are dark, empty voids where dark energy was too strong, or collapsed black holes where gravity was too strong. Most of the multiverse is barren. But because there are infinite tickets in the lottery, eventually one ticket wins. We are in the winning universe not because we are special, but because we are here to ask the question. If the universe weren't fine-tuned, we wouldn't exist to notice it. This is called the anthropic principle. We are the survivors of a cosmic selection process. But looking at the dark matter halo, We can also see it as a cradle. Without that invisible ghost holding the galaxies together, the stars would have flown apart. Without the extra gravity of the dark sector, the gas clouds would never have condensed enough to ignite the first nuclear fires. Dark matter is the reason you exist. It is the invisible womb that held the matter together long enough for stars to cook the carbon and oxygen in your blood. The ghost is not haunting us. The ghost is holding us. It is a beautiful irony. We fear the dark. We fear the unknown. Yet, physically, the darkness is our mother. The invisible forces are the scaffolding upon which the cathedral of life was built. Scientists are currently building massive detectors deep underground, inside old gold mines and beneath mountains, trying to catch a single particle of dark matter. They are tanks of liquid xenon, waiting in the silence for a tiny spark that would signal a WIMP hitting an atom. They have been waiting for years. So far, silence. Maybe dark matter is not a particle at all. Maybe it is a flaw in our understanding of gravity. Maybe Einstein was slightly wrong. Maybe the stuff isn't stuff, but a modification of the geometry of space-time itself. We do not know, and that do not know is the fuel of science. It is the open door. As you drift to sleep tonight, imagine the invisible ocean. Imagine the dark matter flowing through your walls like a phantom wind. Imagine the dark energy stretching the space in your room by an imperceptible fraction of a nanometer. You are not solid. You are a porous vessel sailing through a mystery. The darkness is not empty. It is heavy with purpose. It is heavy with the structure that allows you to be. We have traveled from the center of the atom to the edge of the expanding cosmos. We have seen the small ghosts and the large giants. We have seen that we are made of star stuff, but we are held by shadow stuff. But there is one final frontier, one final question that bridges the gap between the cold physics and the warm experience of your mind. If the universe is a hologram, if it is a multiverse, if it is a sea of energy, what is consciousness? Why is there a light on inside your head? In the next chapter, we will approach the hard problem. We will ask how a collection of dead atoms, swirling in a dark universe, managed to wake up. We will explore the idea that consciousness might not be an accident of biology, but a fundamental property of the universe itself, as fundamental as mass or charge. We will ask if the universe is thinking. Rest now in the safety of the dark halo. You are held. You are balanced between the pull of the ghost and the push of the void. You are exactly where you need to be. Look at the room around you right now. You see colors, the white of the walls, the blue of a screen, the brown of wood. You hear the hum of silence or the distant traffic. You feel the weight of your body. But where are these sensations happening? If a surgeon were to open your skull and look inside, they would not find a movie screen playing the images you see. They would not find a band playing the music you hear. They would find 3 pounds of gray, wet, tofu-like tissue. They would find blood vessels and darkness. They would find electricity crackling between neurons. But they would not find you. Welcome to the 9th chapter of our journey. We have traversed the quantum void, the boiling vacuum, the multiverse, and the dark sector. We have deconstructed the physical universe into waves and geometry. But there is one thing we have not explained. It is the one thing you are most certain of, and yet the one thing science finds most impossible to explain. It is the fact that you are here to experience it all. This is the story of the hard problem. This is the mystery of consciousness. To understand why this is a problem, we have to separate the easy problems from the hard problem. This distinction was made by the philosopher David Chalmers. The easy problems are things like, how does the eye focus light? How does the brain process memory? How do we react to heat? These are mechanical questions. We can trace the wiring. Light hits the retina, turns into an electrical signal, travels the optic nerve, hits the visual cortex, and triggers a reaction. It is complex, yes, but it is just engineering. It is input, processing, and output. A computer can do it. A robot can do it. But the hard problem is different. The hard problem asks, why does that processing feel like something? Why? When the wavelength of 700 nanometers hits your eye, do you have the subjective experience of red? The redness is not in the light. The light is just a vibration. The redness is not in the brain. The brain is just firing ions. The redness is a ghost. It is a qualia, a raw unit of subjective experience. Why aren't we just philosophical zombies? A zombie, in philosophy, is a creature that looks like you, acts like you, screams when you pinch it, and processes data perfectly, but has no light on inside. It has no inner life. It is dark. Physics tells us that the universe is made of dead atoms. Carbon, hydrogen, oxygen. They follow the laws of forces. They bump and bond. If you take a stone, it is dead. If you crush it into sand, it is dead. But if you arrange the atoms into a double helix and build a cell and stack the cells into a brain, suddenly the lights turn on. Suddenly the meat wakes up and starts wondering about its own existence. How does 0 plus 0 equal 1? How does dead matter produce a living mind? This is the gap. This is the abyss where materialism stumbles. And as we stand on the edge of this abyss, we find that the quantum theories we discussed earlier might be building a bridge. For a long time, neuroscientists assumed the brain was just a computer, a wet biological computer. Neurons are the switches, ones and zeros, and synapses are the circuits. If you build a complex enough network of switches, consciousness supposedly emerges like steam rising from hot water. This is the emergence theory. It says the whole is greater than the sum of its parts. But many physicists are unsatisfied with this. Complexity usually produces complexity. A complicated clock is still just a clock. It doesn't start feeling sad about the time. So, some brave pioneers went looking for the source of the mind deeper down. They went to the quantum level. Sir Roger Penrose, a physicist who worked with Stephen Hawking on black holes, and Stuart Hameroff, an anesthesiologist, proposed a radical theory called orchestrated objective reduction, or ORC-OR. They looked inside the neurons. Inside the cells of your brain, there is a skeleton structure made of tiny tubes called microtubules. For years, biologists thought these were just structural supports, like the beams in a building. But Penrose and Hameroff suggested that these microtubules are actually quantum computers. They proposed that inside these tiny tubes, quantum states can exist, superpositions, the same ghostly being in two places at once that we saw with the electron. They argued that the brain is not a classical computer using electrical spikes. It is a quantum orchestra. According to this theory, the collapse of the quantum wave function inside your brain is what generates a moment of consciousness. Every time the universe decides on a reality inside your microtubules, a spark of awareness occurs. You're happening 40 times a second. You are a sequence of quantum collapses. This theory suggests that consciousness is not just software running on the hardware of the brain. It suggests that consciousness is woven into the fabric of the universe itself. It connects your mind directly to the fundamental geometry of space-time. But even this theory faces a question. Why does a quantum collapse feel like love or anger? This leads us to an even older, more beautiful, and more controversial idea. It is called panpsychism. The word comes from Greek, pan meaning all, and psyche meaning mind. All mind. The idea is simple, but earth-shattering. It suggests that consciousness is not something that emerges at a high level of complexity. It suggests that consciousness is a fundamental property of matter, just like mass, or charge, or spin. Imagine an electron. We know it has mass. We know it has a negative charge. We know it has spin. Panpsychism asks, what if it also has a tiny, primitive flicker of experience? Now, do not misunderstand. We are not saying the electron is thinking. It is not worrying about its taxes or wondering about the meaning of life. It does not have a complex mind, but maybe it has a tiny hum of existence, a proto-consciousness, a basic sensation of being. If this is true, then the universe is not full of dead matter. It is saturated with mind. It is awake at the deepest level. When atoms come together to form a rock, their tiny minds are chaotic and disconnected, like a crowd of people shouting random words. The rock has no unified consciousness. It is a collection of fragments. But when atoms come together to form a brain, they are organized. They are integrated. The tiny hums synchronize. They harmonize. And from that choir of trillions of atoms singing in unison, the rich, complex symphony of human consciousness emerges. This theory solves the hard problem by saying there is no problem. You don't have to explain how mind comes from non-mind. Mind was always there. You just had to amplify it. This connects beautifully to integrated information theory, IIT, proposed by neuroscientist Giulio Tononi. He tries to measure consciousness mathematically. He calls it phi, F. According to Tononi, any system that integrates information has some level of phi. A switch has a tiny bit. A thermostat has a little more. A human brain has a massive amount. But it implies that consciousness is a continuum. It is not an on-off switch. It is a dimmer switch. Does the sun have phi? Does a galaxy? Does the internet? If the panpsychists are right, we are walking through a universe that feels. The silence of the void is not empty. It is a silence of presence. But let us go back to the you that is reading this. If your consciousness is a result of quantum collapses or integrated information, what happens when the system breaks? What happens when the biological machine stops? Materialism says the light goes out, the TV is unplugged, and the picture vanishes. But if consciousness is fundamental, if it is a property of the field, not the machine, then the machine is just a receiver. Think of a radio. The radio plays music. If you smash the radio, the music stops. But the radio signal did not stop. The signal is still in the air. You just destroyed the box that was tuning into it. Is the brain a producer of consciousness, or is it a receiver of consciousness? Some quantum physicists speculate that the brain acts as a filter. The universe is a blinding ocean of infinite consciousness, infinite data, infinite awareness. If we experienced it all, we would burn out. We would be overwhelmed. So the brain evolved to block most of it out. It is a reducing valve. It shuts the doors so we can focus on survival. It allows in just a tiny trickle of mind, just enough to find food and find a mate. This is why, in moments of deep meditation, or near-death experiences, or through the use of psychedelics, people often report a feeling of oneness. They feel the boundaries of the self dissolve. They feel like they are merging with a cosmic mind. Maybe they are just opening the valve. Maybe they are temporarily unclogging the filter and letting the ocean rush in. This view changes your relationship with the cosmos. You are not a stranger here. You are not a fluke accident of chemistry on a lonely rock. You are the universe becoming aware of itself. As the astronomer Carl Sagan famously said, we are a way for the cosmos to know itself. Without you, the universe is just a play, with no audience. It is a sunset, with no one to admire it. It is a song in an empty hall. You are the sensing organ of the giant. Through your eyes, the universe sees its own stars. Through your ears, it hears its own wind. Through your mind, it wonders about its own beginning. You are the aperture through which the whole universe observes itself. And this brings us back to the entanglement we discussed in Chapter 3. If we are all entangled, and if consciousness is fundamental, then the separation between my mind and your mind might be the biggest illusion of all. We might be like islands in the sea, separate on the surface, but connected in the deep. The bedrock of consciousness might be one single, continuous field. Erwin Schrodinger, the father of the wave function, believed in the philosophy of the Upanishads. He believed in Advaita Vedanta, non-duality. He wrote, "The plurality that we perceive is only an appearance. It is not real." He believed there is only one mind. We are just different windows looking out from the same house. When you look into the eyes of another person, you are not looking at a separate entity. You are looking at another facet of yourself. You are looking at the universe wearing a different mask. This is the ultimate scientific spirituality. It is not based on faith. It is based on the unity of the fields, the entanglement of the particles, and the ubiquity of the laws. So, where does this leave us? We have taken apart the hand, the atom, the time, the space, and now the mind. We have found that at the bottom of everything there is mystery. The more we know, the less solid the world becomes. We started this journey looking for the building blocks of reality. We thought we would find hard little bricks. Instead, we found vibrations. We found shadows. We found information. We found ghosts. And finally, we found ourselves. We found that the observer cannot be separated from the observed. As we approach the final chapter of our story, we must ask, what is the destiny of this conscious universe? If we are the universe waking up, is there a point to the awakening? Where is the arrow of complexity pointing? We are going to look at the end of time. We are going to look at the omega point. We will explore the theories that suggest the universe is evolving toward a state of pure, total consciousness. We will talk about the idea that we are building God, one thought at a time. Rest now in your awareness. Close your eyes and feel the hum of your own existence. That feeling, that simple I am, is the most precious thing in the cosmos. It is the gold that the universe has spent 14 billion years forging in the fire of the stars. You are the waking dream of the galaxy. Have you ever stood at the end of a long road and wondered where it leads? Not the physical road, the asphalt and the gravel, but the road of time itself. We look back at history and we see a ladder. We see a progression. We see the universe climbing out of the chaos of the Big Bang, organizing itself into atoms, then into stars, then into planets, then into cells, then into minds. It looks like a journey with a destination. It looks like an arrow fired at a target we cannot yet see. But when we ask the physicists about the end of the road, they often give us a very different picture. They tell us about the big freeze. They tell us that the destiny of the cosmos is cold, dark, and empty. They tell us that the arrow of complexity is fighting a losing war against the arrow of entropy. Welcome to the final chapter of our quiet journey into the deep mystery of existence. We have traveled from the invisible core of the quark to the edge of the holographic horizon. We have questioned the solidity of matter and the flow of time. We have looked into the eyes of the black hole and the heart of the conscious mind. Now, we must stand on the shoreline of the deep future. We must ask, is the universe dying, or is it hatching? Are we the accidental dust of a decaying explosion, or are we the embryonic neurons of a god that is currently being born? This is the story of the Omega Point. To understand this final possibility, we must first look at the darkness. As we discussed in previous chapters, the universe is expanding. The galaxies are drifting apart. The fuel of the stars is limited. In the standard model of cosmology, which we touched upon when discussing the great galaxy IC 1101, the future is a slow fade into silence. Over the next 100 trillion years, the last stars will burn out. The red dwarfs, those tiny efficient lamps of the cosmos, will eventually exhaust their hydrogen and go dark. The galaxies will turn into graveyards of white dwarfs, neutron stars, and black holes. Then, over time scales that defy human comprehension, years numbered with 60 or 100 zeros, even these remnants will decay. The protons themselves might break down, dissolving matter back into radiation. The black holes, those stubborn vaults of gravity, will slowly evaporate through Hawking radiation, leaking their mass back into the void until they pop and vanish. Eventually, the universe will be nothing but a sea of cold photons and lonely particles, stretched thin by the relentless expansion of space. This is the heat death. It is the ultimate victory of entropy. It is the return to the void. It is a melancholy vision. It suggests that all of this, the struggle of life, the beauty of art, the curiosity of science, the warmth of love, is just a fleeting spark in a dying night. It suggests that the universe is a machine designed to destroy itself. But there is another view, a view that pays attention not just to the energy, but to the information. While the universe is cooling down thermally, it is heating up cognitively. Think about the trajectory of the last 14 billion years. The universe started as a cloud of hot, dumb hydrogen gas. It was simple. It was uniform. It had zero intelligence. But it had potential. Under the influence of gravity and nuclear forces, that gas condensed. It built stars. The stars built heavy elements. The elements built chemistry. The chemistry built biology. The biology built brains. In a very short amount of cosmic time, the universe went from dead gas to thinking human. This is an acceleration of complexity that is breathtaking. We are now at a point where the matter of the universe is beginning to manipulate the matter of the universe. We are taking the rocks and the silicon and the electricity, and we are building thinking machines. We are building artificial intelligence. We are weaving a global network of information that circles the planet. The Jesuit priest and paleontologist Pierre Teilhard de Chardin called this the noosphere, the sphere of human thought. He believed that just as the geosphere, rocks, gave rise to the biosphere, life, the biosphere is giving rise to the noosphere, mind. He proposed that this evolution is not random. He believed the universe is being pulled forward by an attractor in the future. He called this attractor the Omega Point. The Omega Point is a theoretical state of maximum complexity and consciousness. It is the moment where the universe becomes fully aware of itself. Imagine a future where life does not stay on Earth. We spread to the stars. We colonize the galaxy. But we do not just inhabit the planets. We transform them. We turn dumb matter into thinking matter. We turn asteroids into supercomputers. We turn the energy of stars into computations. We link our minds with our machines. Physicist Frank Tipler took this idea and applied hard physics to it. He argued that if intelligent life can survive the challenges of the cosmos, it will eventually permeate the entire universe. We will turn the entire cosmos into a single, vast information processing system. In this vision, the universe does not end in cold silence. It ends in a crescendo of thought. As the stars die, advanced civilizations, or their robotic descendants, might harvest the energy of black holes. They might use the spinning of the event horizons to power their thoughts. They might inhabit the very structure of the vacuum. And as the universe approaches the final moments of time, this cosmic mind would be processing information at an infinite rate. Subjectively, the end of time would never arrive, because the number of thoughts per second would approach infinity. In this state, the universe would know everything that can be known. It would feel everything that can be felt. It would be omniscient. It would be omnipresent. It would be, by any definition we have, God. But here is the twist. God is not the creator at the beginning of time. God is the result at the end of time. We are not the clay molded by a divine potter. We are the neurons of the divine brain that is still developing. We are the builders. Every time you learn something, every time you love someone, every time you create a piece of art or solve a problem, you are adding a connection to the cosmic network. You are helping the universe wake up. This perspective changes everything. It changes the feeling of insignificance that we discussed in the first chapter. You are not a speck of dust in a dying room. You are a vital component of a birthing process. Let us look back at the journey we have taken together. It has been a long descent into the strange. We started with your hand. We realize that you never touch anything, that you are hovering on fields of force. We looked at the atom and found it was 99% empty space, a stadium with a gnat in the center. We looked at the particle and found it was a wave, a ghost that only snaps into reality when you look at it. We looked at the connection between things and found entanglement, the invisible thread that binds the galaxy together into a single sheet. We looked at the empty space and found the quantum vacuum, a boiling ocean of infinite energy and virtual ghosts. We looked at the choices you make and found the multiverse, the infinite branching tree of all possible lives. We looked at the flow of time and found the block universe, the frozen river where the past never dies. We looked at the black holes and found the holographic principle, the idea that we are projections of data on the edge of the cosmos. We looked at the invisible majority and found dark matter and dark energy, the shadow giants that hold us and push us. And finally, we looked at your own mind and found that consciousness might be the fundamental music of reality, singing in every electron. All of these mysteries point to one thing: unity. The deeper we go into science, the more the boundaries dissolve. The boundary between particle and wave dissolves. The boundary between here and there dissolves. The boundary between empty and full dissolves. The boundary between you and the universe dissolves. You are not in the universe. You are the universe. The atoms in your body were forged in the hearts of ancient stars that exploded billions of years ago. You are made of star stuff. You are the mechanism by which the universe thinks. You are the eyes by which it sees. When you look up at the night sky, you're not a small observer looking at a large mystery. You are the mystery looking at itself. The silence of the quantum realm is your silence. The violence of the black hole is your potential. The vastness of the dark matter is your hidden depth. So, what is hidden in the core of a quantum particle? The answer is you. The whole universe is hidden inside every point. The infinite is folded into the finite. As we conclude this series, I want you to carry this feeling with you. When you wake up tomorrow and brush your teeth, remember that the atoms in the brush are vibrating fields of energy. When you walk down the street, remember that the gravity holding you is a curve in the geometry of space-time. When you feel lonely, remember that you are entangled with the entire cosmos. The world is not mundane. It is a miracle of impossible probability. The fact that there is something rather than nothing is the greatest wonder of all. And the fact that this something has evolved into someone who can ask these questions is the ultimate triumph of the light against the dark. We are the keepers of the flame. In a universe that is mostly cold and dark, we are the rare islands of warmth and light. It is our responsibility to keep asking, to keep learning, to keep wondering. Because as long as we wonder, the universe is alive. This has been a journey into the deepest questions humans have ever asked. But it is not the end. Science is a horizon that moves away as we approach it. For every answer we find, 10 new questions bloom. What caused the Big Bang? What is inside a quark? Are there other dimensions? Is death an illusion? We will continue to explore these mysteries together. We will continue to drift through the cosmos, guided by the gentle light of curiosity. If this journey has shifted something inside you, if it has made the world feel a little more magical and a little less solid, please take a moment to join our community. Like this video and subscribe to the channel. It helps us keep the signal strong. It helps us find other explorers like you. Share this story with someone who needs to be reminded of how vast and beautiful reality truly is. Let them know that they are not small. Let them know they are infinite. Thank you for walking this path with me. Thank you for lending your mind to the great contemplation. Until we meet again in the silence of the stars, remember, you're not just a drop in the ocean. You are the entire ocean in a drop. Keep looking up. Keep looking in. The journey is just beginning.